be paired with more traditional gray infrastructure. We're fortunate to have representatives from NOAA, the Department of Agriculture, and the U.S. Army Corps of Engineers on today's panel. I'm eager to hear from our witnesses about their work on natural and nature-based infrastructure in coastal, rural, and urban and suburban communities across the country, and explore what else the federal government can do to support the implementation of nature-based infrastructure. As our climate changes, so too does the way we look at infrastructure and resilience. Nature-based infrastructure will need to play a bigger role as we move into the future. I hope through our conversations today, we can better pinpoint the specific areas of research that the federal government should prioritize and share with our communities. The chair now recognizes Ranking Member Bice for an opening statement.
Thank you, Chairwoman Cheryl, and thank you to our entire panel of witnesses for appearing before the subcommittee and sharing their expertise with us this afternoon. Infrastructure is often mentioned topic that traditionally comes with bipartisan support and agreement. We all understand that America's infrastructure has been slowly deteriorating over the last few decades and requires significant investment in nationwide projects to avoid existing structures from crumbling entirely. But today's hearing is about a side of infrastructure that might not be as popular or even entirely understood: nature-based or green infrastructure. While most people understand infrastructure as the man-made roads, buildings, and structures we see every day, infrastructure can also include natural systems in nature like wetlands, green roofs, or bioswales. While there are varying definitions for this specific area and what is included for today's hearing, I'm going to refer to it as green infrastructure and focus on projects that intentionally align natural and engineering processes by combining traditional infrastructure with nature-based solutions. That alignment is important because while nature and nature-based solutions can be effective, sustainable, and resilient on their own, most communities face persistent hazards like erosion, storm surges that require components of traditional infrastructure to ensure the maximum safety of the community. So to me, green infrastructure should always be a hybrid approach that combines the best of both worlds: environmental components that are naturally occurring or mimic nature, and long-lasting, effective man-made components. That is the most reasonable way to build or restore high-quality, low-cost, resilient communities. I am particularly pleased to welcome Dr. Sherry Hunt as a witness to testify on her extremely valuable work. She's based in Stillwater, Oklahoma, and like me, ranking member Lucas is a proud graduate of Oklahoma State University. Go Pokes. But more importantly, as an ag engineer working on the USDA Ag Research Service, Dr. Hunt's work has led to the development of designs and methodologies being used to rehabilitate thousands of dams across the country. Her research focuses on aging and weakened dams, something that Oklahoma knows a little bit about, many of which are in remote or rural communities, and her designs, methods, and simulations can safely extend the service life of these dams to protect life and property. That is extremely important to the communities that might not be high on a priority list for federal assistance. But as we discuss the benefits of natural infrastructure, it is important we keep all options on the table and understand it is not a one-size-fits-all approach. As Dr. Hunt will tell us today, it is not as easy as just planting trees on the bank of a river or slowing water flow with logs and branches like beavers. Long-term safe solutions require man-made structures like the roller compacted concrete she used for a spillway over the top of dams near areas with increased population growth. I look forward to hearing from all of our witnesses on how ARS and Dr. Hunt's research can contribute to the broader conversation of green infrastructure. Although it might seem untraditional, we should encourage collaboration and data sharing between research agencies like NOAA and regulatory agencies like the Department of Ag. NOAA is undoubtedly well equipped to research coastal management issues, but that work may not necessarily apply to inland or rural communities like we have in Oklahoma. Therefore, it is my hope that today's hearing can not only identify research gaps, but also ways agencies can come together to address the full range of communities seeking to improve their infrastructure with nature-based solutions. Again, I want to thank the witnesses for being here this afternoon, and I look forward to your testimony. Madam Chairwoman, I yield back the balance of my time.
Thank you. At this time, I'd like to introduce our witnesses. Our first witness is Dr. Stephen Thur. Since 2017, Dr. Thur has been the director of NOAA's National Centers for Coastal Ocean Science. Dr. Thur oversees NCCOS's NCOS, four primary research areas: coastal change, marine spatial ecology, social science, and stressor impacts and mitigation. Our next witness, as we heard, is Dr. Sherry Hunt. Dr. Hunt is the Supervisory Civil Engineer of the Hydraulic Engineering Research Unit at the Agricultural Research Service of the United States Department of Agriculture, USDA, in Stillwater, Oklahoma. Dr. Hunt is an internationally recognized authority in physical modeling of hydraulic structures and embankment breach. Our final witness today is Dr. Todd Bridges. Dr. Bridges is the U.S. Army Senior Research Scientist for Environmental Science. Dr. Bridges' responsibilities include leading research, development, and environmental initiatives for the U.S. Army and the U.S. Army Corps of Engineers. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you all have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. Thur.
Good afternoon, Chairwoman Cheryl, Ranking Member Bice, and members of the subcommittee. Thank you for the opportunity to testify today. My name is Dr. Stephen Thur, and I'm the director of the National Centers for Coastal Ocean Science in the National Oceanic and Atmospheric Administration. I appreciate the subcommittee's interest in exploring nature-based infrastructure and associated research gaps. My testimony today will highlight how NOAA is supporting research on the effective use of nature-based infrastructure as a means to enhance coastal resilience. The evidence is clear. Weather and climate disasters are already devastating our communities, and we must prepare ourselves for the unavoidable impacts to come. In 2021, there were $20 billion disasters in the United States, and total damages were approximately $145 billion. Along the coast, sea level rise, hurricanes, harmful algal blooms, flooding, and other ocean-related climate risks increasingly threaten people and infrastructure. At the same time, coastal ecosystems that provide natural protection from coastal flooding and erosion are shrinking and degrading due to coastal development, warming waters, and more. The use of nature-based infrastructure offers the potential for scenarios with multiple benefits. For instance, it is possible to design nature-based features that are as or more effective than traditionally engineered gray solutions in reducing the flood risk to nearby communities. Both nature-based and traditional solutions may satisfy risk reduction requirements. However, nature-based solutions may also enable the same funding to advance multiple objectives holistically, such as endangered species recovery, fisheries production, climate adaptation, and access for recreational use. Some of these natural infrastructure solutions may involve an increase in the cost of the project relative to what would be strictly necessary for just the flood risk reduction benefits. Such modifications and potential increased expenditures may be a more efficient use of federal funding overall to yield the maximum net benefit for society. Single-purpose coastal projects have been the primary approach for the past half-century for both water management and environmental programs. For the next half-century, nature-based infrastructure projects provide an opportunity to simultaneously address multiple priorities. I would like to highlight 3 categories of research needs. First, we need to assess the performance of nature-based infrastructure. There are perceived uncertainties in the performance of nature-based infrastructure, and these are often cited as a barrier to implementation. To address this research gap, NOAA is partnering with federal and state agencies to evaluate the less understood aspects of their effectiveness. NOAA's National Centers for Coastal Ocean Science will soon start evaluating how some existing nature-based infrastructure projects have evolved since their initial construction. In our experience, most of these projects may not have extensive monitoring data, but comparison of current conditions to as-built conditions will allow for an assessment of how the feature has performed and evolved over time. Second, we need to quantify the ecosystem benefits of nature-based infrastructure. There is limited empirical data quantifying the benefits of some nature-based features beyond their primary purpose for flood risk management, such as providing habitat and carbon sequestration. NOAA entered into an interagency agreement with the U.S. Army Corps of Engineers through which we are monitoring newly installed Corps projects, collecting empirical data on long-term effectiveness of nature-based features in improving ecosystem services. And third, we need to employ social science techniques to value benefits and address public perception of nature-based infrastructure. New research is starting to put a dollar value on the risk management benefits provided by nature-based infrastructure. We need further study to value all ecosystem services of nature-based infrastructure so that this information can be appropriately factored into benefit cost analyses and associated decisions on coastal infrastructure investment. Understanding and addressing perceptions about the effectiveness of nature-based solutions is needed in parallel with valuation studies. As green infrastructure has been used less commonly than traditionally engineered coastal projects in recent decades, there is sometimes hesitancy to use nature-based solutions because they are less familiar. Social science research is a current gap that must be addressed to enable decision makers to effectively communicate and overcome such hesitancy. In conclusion, nature-based solutions have a significant role to play. Our national discussion on infrastructure investment must incorporate elements of sustainability to provide fully for the health, welfare, economic vitality, and socially just climate resilience of our communities. Thank you.
Wow, that was exactly 5 minutes. Thank you very much, Dr. Thur, and a wonderful presentation. Next, we'll hear from Dr. Hunt.
Chairwoman Cheryl, Ranking Member Bice, and members of the subcommittee, thank you for this opportunity to provide testimony on this important topic. I'm Dr. Sherry Hunt, Supervisory Civil Engineer of the U.S. Department of Agriculture's Agricultural Research Service, Hydraulic Engineering Research Unit in Stillwater, Oklahoma. I also serve as our agency's dam safety officer and have been a federal researcher for nearly 22 years. The Hydraulic Engineering Research Unit is a one-of-a-kind facility that relies on gravity flow water for testing small to prototype scale models of channels and hydraulic structures, including earthen dams, spillways, and grade stabilization structures. Today, the Hydraulic Engineering Research Unit's mission is to develop criteria for the analysis and design of conservation structures and channels for the conveyance, storage, and measurement of runoff waters. For more than 80 years, ARS scientists have been central to providing research support for the USDA's Small Watershed Program. This program combines conservation practices in the watershed with earthen, multi-purpose dams on tributary streams. The design standards developed by our scientists contributed to the construction of nearly 12,000 dams and associated conservation practices in more than 2,000 watershed projects encompassing 160 million acres in 47 states. These dams provide the U.S. an estimated $2.3 billion in annual benefits through flood protection, rural and municipal water supplies, water for agricultural and energy production, recreation, and tourism. ARS scientists remain committed to providing research support for these aging dams. ARS scientists develop standardized dam rehabilitation design criteria for routing floodwater around or over these dams impacted by the transition from rural to urban settings. The Natural Resources Conservation Service expects to apply this design criteria to approximately 1,200 program-funded dams with an anticipated construction cost savings of up to $1.2 billion. In addition, ARS scientists conduct research to quantify and predict erosion processes to improve design and analysis tools for earthen dams. I collaborate with a diverse group of stakeholders representing federal agencies, state dam safety offices, private consultants, and national and international scientific peers for developing and implementing evolving technology like the physically based simplified earthen dam erosion and failure prediction model wind dam. Our design standards, engineering tools, and models have been successfully adopted by our collaborators like the U.S. Army Corps of Engineers. Climate and environmental change and human activities are threatening water and land resources and economic growth across America because of the aging dam infrastructure. It should be noted that approximately 76,000 dams on the U.S. National Inventory of Dams are earthen, which are more susceptible to these threats. The ARS is committed to addressing these challenges as we collect larger volumes and more complex data, but this too brings challenges in data acquisition and management, as well as how we share data. For instance, current dam monitoring systems available have drawbacks as they don't provide data on water quality or quantity for real-time use by emergency managers, irrigation districts, and farmers and producers. These data, coupled with decision support tools like smart applications, will improve the sustainability of agricultural production for a growing population in the U.S. ARS scientists are committed to taking a holistic approach that engages collaborators through our partnerships for data innovations, PDI for short. PDI is a field engage effort to innovate the way we collect, handle, store, use, and serve data. Leveraging public and private partnerships will create customized solutions to reduce the time researchers spend on data management so we can focus more time on the science. In closing, the question that comes before us today is how do we address the challenges that affect the sustainability of our agricultural production, water resources, and our economic growth that these dams provide? The answer is simple. Through collaborative partnerships and a holistic science-based approach to develop cloud-based technologies and engineering tools for standardized data collection and management, dissemination of data for aiding sustainable resource management and precision agriculture, and decision support tools for assessing the social and economic benefits of our water and land resources. The ARS is committed and poised to be the global leader in agricultural discoveries through scientific excellence. Thank you.
Thank you, Dr. Hunt. And as a point of personal privilege, I just want to ask, is that the hydraulic engineering research unit behind you in the picture that you have up on your screen?
It is. It is. And that is a earthen dam back there.
Oh, great. Thank you so much. Sorry, I muted myself. Finally, we will hear from Mr. Todd Bridges.
Chairwoman Sherrill, Ranking Member Bice, Chairwoman Johnson, Ranking Member Lucas, and members of the committee, I'm honored to testify before you today. I am the Army's Senior Research Scientist for Environmental Science at the U.S. Army Engineer Research and Development Center. And among other responsibilities, I serve as the national lead for the Corps of Engineers Engineering with Nature initiative that is working to support sustainable, resilient infrastructure systems for the 21st century. In the United States, we are blessed with an abundance of natural capital. 3,000 miles of barrier islands along our coastlines, thousands of miles of mainland beaches and dunes, and 100 million acres of wetlands in the lower 48 states alone. Wetlands along the Northeast Atlantic coast helped to avert $625 million of flood damage during Hurricane Sandy. And the 500,000 acres of mangroves around Florida helped to avert more than $1.5 billion in flood damages during Hurricane Irma in 2017. In our work, nature-based solutions refers to the intentional and substantial use of natural systems to support water resources solutions. The Corps has made significant use of such approaches for decades, and in 2010, the Corps established the Engineering with Nature initiative to advance the integration of human engineering and natural systems. We've published 2 volumes of Engineering with Nature and Atlas. These books showcase 118 examples of constructed projects around the world that illustrate what engineering with nature practice looks like, along with the economic, environmental, and social benefits they produce. 50 of these projects were built by the Corps of Engineers. The example projects include Horseshoe Bend Island in the Atchafalaya River of Louisiana that was constructed through beneficial use of sediment dredged from the navigation channel. And that island's providing 80 acres of habitat in addition to engineering benefits. Hamilton and Sears Point wetland projects in California are restoring 1,500 acres of wetlands while supporting coastal resilience with respect to sea level rise in San Francisco Bay. Our work on engineering with nature over the last decade has allowed us to identify many of the key enablers for advancing engineering with nature, including developing a new science and engineering practice, fostering creative planning and design, documenting the diverse benefits of nature-based solutions, communicating widely to facilitate progress, preparing practitioners through education and training, and leveraging the power of collaboration across organizations and sectors to innovate. And likewise, we've recognized that challenges exist. Conventional engineering and nature-based solutions may not align with the community's vision. All solutions, whether conventional or nature-based, require land to build the solutions at the scale the problems require, and hesitancy regarding new engineering practice. We're fueling our progress through collaboration and partnering. The Corps of Engineers established the Network for Engineering with Nature with the University of Georgia in 2020 to engage across sectors and universities around the country, including the University of Oklahoma, Arizona State University, the University of Florida, the University of Delaware, among others. And we're partnering with other government agencies at the federal and state level, such as NOAA, including Dr. Thur and his colleagues at NCOS, the U.S. Fish and Wildlife Service, the National Park Service, the California Department of Water Resources, among others. The Corps has established national engineering with nature practice leads for coastal and river applications to complement the leadership being provided by the 6 engineering with nature proving grounds at our district offices across the Corps. For example, we are working with Galveston District on nature-based coastal resilience across Texas, with Philadelphia District on Back Bay nature-based solutions in New Jersey, and with St. Louis District at the intersection of river and agricultural landscapes. Dialogue and collaboration with the private sector, nonprofits, and financial institutions is helping us understand the business case for nature-based solutions. We're collaborating with organizations across the Department of Defense to support mission resilience at installations through engineering with nature, with the Department of the Army, with the Navy, with the Air Force and its $5 billion rebuild of Tyndall Air Force Base in Florida following Hurricane Michael, and with the Defense Advanced Research Projects Agency, or DARPA, and its Reef Fence program. Nature-based solutions are being built around the world as standalone projects and, importantly, in combination with conventional engineering to produce multi-purpose benefits. I'd like to thank you again for the invitation to testify before the committee, and I look forward to answering your questions.
Thank you so much, Dr. Bridges. Before we proceed, I would like to bring to the subcommittee's attention 4 letters for the record from organizations that engage in nature-based infrastructure. These include submissions from the Environmental Defense Fund, the National Wildlife Federation, the National Estuarine Research Reserve Association, and the Association of State Floodplain Managers. These letters highlight research gaps with respect to nature-based infrastructure and support additional federal investment in this research. Without objection, I am entering these documents into the record. At this point, we will begin our first round of questions. The chair recognizes herself for 5 minutes. In my opening remarks, I told you about my visits to waterways in my northern New Jersey district. One of the problems I've heard about from my constituents is that historically deeper waterways have seen their depths reduced from the buildup of silt. For example, along the Whippany River in Hanover, New Jersey, I'm told sections that used to be 20 feet deep are only 4 feet deep now due to the silt buildup. This dramatically reduces the capacity of the river to handle increased water flow from heavy rain events, resulting in waters overtopping the riverbanks and flooding nearby communities. Dr. Bridges, I understand that part of the solution in such instances is to remove obstructions in and along the river and increase the channel depth. But I'm interested in hearing about how nature-based improvements can be a sustainable part of the solution. Can you tell me about the Army Corps' projects where measures like replanting vegetation along eroding riverbanks and de-snagging have reduced long-term flooding?
Thank you for the question, Chairwoman. I think there are a whole range of opportunities. You've mentioned a few of them, including riparian zone restoration. Soil that is eroding off of the landscape, is ending up in waterways and creating this enhancement in sedimentation, which we then have to, if you will, artificially or through engineering means correct through dredging, for example. I would mention again this Horseshoe Bend Island project that I mentioned. I know it's a completely different system, but one of the engineering benefits we derived there is that when this 80-acre island was built with sediment that we dredged from the navigation channel, the hydraulics of the system changed. such that now that portion of the river actually moves sediment more efficiently and effectively than it did before. So that we now save about $4 million in less dredging costs at that portion of the navigation channel because of that island. And that island is natural. We provided the sediment to the river. The sediment built the island. I mean, the river built the island. And it's essentially a nature-based river training structure. And so we're getting engineering benefits from nature at the same time that we're getting environmental as well as social benefits.
Thank you. And are there other natural infrastructure ideas that can be used to reduce stormwater runoff into these waterways?
The question's for me. Again, I think there are a whole range of them. When we can control overland flow of water using such features as green infrastructure and bioswales and detention areas, it also provides an opportunity to control the flow of soil or sediment into systems. And I think it's a combination of these kinds of measures, including natural measures, but also by restoring landscapes where we have serious runoff. I'm actually borrowing an office at Marine Air Station Yuma in Yuma, Arizona right now, where we're having a 3-day workshop on the application of nature-based solutions in arid climates. And soil movement during storms and flooding events in the desert is a very serious problem and moves a lot of sediment, especially after wildfire. But we have to take care of the landscape. If we can take care of the landscape, we can reduce the sediment loadings into our river and stream systems.
Well, thank you. And I'm sorry to be picking on you, Dr. Bridges, but my district in North Jersey was devastated by Hurricane Ida, and increased rainfall due to climate change will continue to be a significant burden to my constituents. I'm encouraged by the potential of nature-based infrastructure solutions to help mitigate the effects of severe rainfall and flooding. And this committee has already passed my bill, the Precip Act, which directs NOAA to update precipitation estimates. And I expect to have a full House vote on it soon. I'm wondering if you or Dr. Thur know how that will how improved precipitation estimates will help support the strategic implementation of natural infrastructure.
If I may, Todd. So understanding and predicting the flow of water is critical to most of our economic activity, and NOAA has a huge role to play in that. And I recognize Ranking Member Bice mentioned inland areas in her opening comments as well. So NOAA may not have a direct role in encouraging natural infrastructure inland. Our trust resources are along the coast. However, our science can provide support to those that do have that implementation role. And so we are attempting to model and understand how severe will precipitation events be in the future. So what are the inundation pulses that our natural infrastructure components need to be designed to handle? And so we're providing science solutions and precipitation modeling to our partners, including the Army Corps and localities in inland areas.
Well, thank you. I'm afraid my time is up. This has been very interesting. And so I am now going to turn it over and recognize the ranking member of the subcommittee, Ms. Bice, for 5 minutes.
Thank you, Chairwoman Cheryl. The first question is directed to Dr. Hunt. You're currently undertaking a pretty unique project related to developing cloud-based database networks within the ARS. As Dr. Thur can attest, over the last few years, NOAA has also been working on a similar transition for their models from data to cloud. And I want to start by asking about the effort, the challenges you're facing, and if there are any ideas or suggestions on how NOAA or possibly DOE with their advanced computing power may be able to help you in this effort. And Dr. Thur, you're also welcome to chime in there.
Thank you, Ranking Member Bice, for your question. Yes, we are getting heavily involved in the area of big data, both historic and real time through our partnerships and data innovations, partnering with a number of other ARS scientists as well as federal agencies to pull in data such as the climatology, the meteorology data, that can be used to design, to support the design of these infrastructure. And so some of the areas that we are looking and starting to develop is low-cost sensor networks, using and deploying unmanned aerial vehicles to help us assess these dams and other hydraulic infrastructure, so we can have a better understanding at their performance and how they react to these changing climate, for instance. And so, yes, we are very heavily involved in this area and look to partner with other federal agencies as we already have.
Dr. Thur, would you like to comment on that?
Thank you, ma'am. I would briefly. I would say that NOAA is constrained in our supercomputing capacity. And for weather forecasting in particular, we have about a 1-to-1 ratio between the supercomputing power allocated to operational models for forecasts and research modeling. So that's the R&D side. Other locations, including the European Center, have a 10-to-1 ratio, research to operations. And so we look forward to working with the Department of Energy for the supercomputing capacity that they may have that we can bring to bear on natural infrastructure as well as other challenges.
Thank you for that. And to follow up, Dr. Thur, in your testimony, you said that single-purpose coastal projects have been the primary approach for water management and environmental programs. I understand that your expertise is in coastal science, so this question might quickly move out of your range of knowledge, but on the coast, it's easy to see how green infrastructure can be multi-use, reduces flood risk, and restores fisheries, for example. But I have a feeling it is maybe not that easy for inland states like Oklahoma, which also have water management needs. Can you talk about the potential multi-use projects that NOAA could assist with that are not on the coast, and what research is needed for these projects to yield the maximum net benefits for communities they're located in?
Thank you for the question. I can provide an example. It is not from Oklahoma. It is from a riverine system in Oregon and may be applicable. There in Tillamook, we had a project that was primarily focused on restoring habitat for threatened salmon. However, that project also involved providing flood storage capacity by bringing down earthen levees and restoring the river's access to its historic floodplain. That worked for the salmon to provide additional habitat, but it also, in a 433-acre parcel, reduced flood damage to 4,800 acres in the nearby community. It just so happened we completed the project in 2017. There was a flood in that same year, and there was a dramatic decrease in damage to the infrastructure. And so that's an example of a riverine project we were involved with because of an anadrous species that could be used in inland areas such as Oklahoma.
Perfect. I think for Congressman Feenster and I, who are inland, these types of projects are much more sort of applicable to where we are. And finally, Dr. Bridges, in your testimony, you mentioned the Army Corps has established a network for engineering with nature in 2020, and you're going to be partnering with the University of Oklahoma, among other institutions. Can you briefly talk about the partnership and the potential benefits?
Yes, thank you very much. Thank you, Member Bice. Collaboration is key to innovation. I mean, it is. And the inland heartland of our country has substantial need and I think substantial opportunity for nature-based solutions. I did a 5,000-mile road trip this summer visiting all sorts of projects and different landscape contexts where I talked about nature-based solutions. I'm going to be in Oklahoma in 2 weeks, meeting with folks at the University of Oklahoma. And one of the first products we're going to generate from this collaboration is a nature-based solutions playbook for the Great Plains. So how can we, across the entire landscape, from rivers and reservoirs and upland areas, identify nature-based solutions that could be used in combination, again, with conventional engineering to provide engineering benefits for flood management, drought management, and everything in between, as well as the broader array of benefits, including recreational benefits, as well as environmental benefits that we can achieve. But I'm firmly committed to the idea that the heartland and the inland, there are many opportunities and needs that we need to satisfy with these approaches.
Perfect. Well, Dr. Bridges, I look forward to maybe connecting with you on that specific project. And Madam Chairwoman, my time has expired, so I yield back.
Thank you. I'm now going to defer to Committee Counsel for the order of recognition.
Mr. Caston is recognized.
Thank you, Madam Chair. Thank you, Committee Counsel, and thank you to all our speakers. I really appreciate your time here. My home state of Illinois has done some really innovative things around cover crop incentive programs, and we're working to try to see if we can build some national legislation that would build on this. As I don't need to tell you, witnesses, there's a ton of benefits from different cover crop practices and increasing soil carbon retention. I think the NRDC found that every 1% increase in soil organic matter leads to 20,000 gallons of water per acre, more water retention in soils, which of course helps with droughts. I'm also consistently intrigued by this. I think it was that actually grows our economy and helps avert climate disaster. Dr. Hunt, I want to start with you. Can you give us a little bit of color on ARS's cover crop and healthy soil research platforms, how they can help us better understand the ability of cover crops to mitigate climate risk? And if you can, my legislative push has been on cover crops. Are there other soil management techniques we should also be thinking about to increase the ability of our soils to hold more carbon?
Very great question, and a little bit outside my area. So that's likely a question for the record that I'll get back to you with from my staff. But what I can tell you is that the research that we provide on infrastructure, for instance, provides many benefits, including irrigation. And I know that isn't necessarily something that's traditionally done in your state, but that's one of the benefits that will help in drought-prone areas. And then we also have other ARS scientists working in various areas. And that's one thing great about ARS as a whole. It's a scientific organization where we coordinate our research and work together to answer some of these bigger problems like you have brought up.
Okay, well, I would love to, if you have some thoughts, let's follow up off the record, because it really is important. I mean, I've said for a long time, there's only 3 things we need to do to avert climate disaster. We need to double our energy efficiency. We need to figure out how to decarbonize hard to decarbonize industries. And then we need to stop CO2 emissions by about 1992, because we've already overshot, and these negative CO2 technologies like in agriculture can help with that. I want to shift, if I could, to Dr. Bridges. There's a company in my district called Profile Products that specializes in nature-based options for soil and erosion control products, and they're trying to be directly responsive to some concerns that the Illinois Department of Natural Resources has raised about that plastic netting that we always see on the sides of roads when we're doing soil retention. That can present a hazard to humans and wildlife, these microplastics that degrade and go into the soils. I'm curious, Dr. Bridges, as you look nationally, what practices can you tell us about for regrowing vegetation as a part of soil erosion for control of levees, dams, authorized projects? And when complying with these environmental standards, is the Corps looking specifically at environmentally sustainable technologies when selecting materials and techniques for these projects?
Thank you, sir, for the question. I would first like to, say amen to your emphasis on soils. Plants and soils are so key, not only to the carbon cycle, but also to the hydrologic cycle. And our ability to kind of invest in plant soil systems, we can solve multiple problems at the same time, including the points you were making with respect to carbon sequestration. But as you say, as you increase the carbon content of soils, that soil is also able to take on more water. So less flows over the surface and potentially into streams and rivers that generate floods. So these things are all connected together. And I think it's one of the benefits of nature-based solutions is that they offer twofers and threefers and fourfers, that we can get at several different problems and challenges with the same investment. We've been making investments in plant systems. In fact, we've published one book on engineering with nature with native plants, how plants themselves are, eco-engineers, and we need to figure out ways to use them more effectively for systems like sand dunes and stabilizing, making sand dunes along our coast more resilient. But as you point out, levees as well as other landscape features. And we're open and very interested in collaborating with the private sector to advance more sustainable practices in regard to soil retention and plant systems overall.
Thank you, and I yield back.
Mr. Feenstra is now recognized.
Thank you, Chairwoman Cheryl and Ranking Member Bice. And thank you to all our witnesses for your testimony and sharing your extensive experience today on this subject. Dr. Hunt, I have the pleasure of serving on the House Agricultural Committee, so I am happy for the opportunity to talk to folks from the USDA. Similar to your home state of Oklahoma, Iowa has a large number of small watershed projects and several earthen dams. We have learned how to fortify these structures dramatically over time, thanks to the research done by the USDA. Moving forward, what other areas do you think we should direct USDA research to help ensure that we can get the maximum use out of our natural infrastructure for generations to come?
Thank you for your question. That is a very good question. And part of the reason that we are spreading out into monitoring and assessing dam performance outside of our traditional physical modeling. But, we learn something every day. One thing I know is that I work with many states like Iowa. And recently they reached out to me about the use of new metal products in pipes for these dams and how that would affect the hydraulic performance of these structures. And this was in partnership with the Natural Resources Conservation Service, where they, had these questions. And so we could look back in our research, but also it's important to recognize these new products are being developed that are being used that still need to be researched to ensure that they are performing as they should. But again, back to the monitoring, that is one aspect that we are truly starting to expand our research on, so we can provide this data and share this data so irrigation districts can use the information to know how much water is available in the reservoir, for emergency managers to know how to mitigate possible flooding downstream. And so that is one area of research that is growing.
Well, thank you. Thank you, Dr. Hunt. Thank you very much. Dr. Thur, this is sort of going down the same vein as Congresswoman Bice. In your written testimony, it heavily focuses on NOAA's work on the coastal mitigation, particularly as it relates to the sea rise. Although my district is not near the coastal bodies of water, our lakes, watersheds, and rivers are of great importance. The Missouri River is a great example, as it borders 6 of my district's most expansive counties. Can you explain how this research might benefit my constituents?
I can, sir. Thank you for the question. As Dr. Bridges has mentioned, there are applications of specific techniques that may be appropriate in both coastal and in riverine systems. And so I do think there is some transferability of research that's done on natural-based infrastructure along the coast that can be transported inland to riverine systems. I would also add that NOAA has an interest in nature-based solutions in freshwater inland areas because of the impacts downstream to our agency's trust resources. So I sit on the Hypoxia Task Force, which is focused on reducing excess nutrients to the Gulf of Mexico, Mississippi River, and work directly with state departments of agriculture to try to do that. The environmental challenge we're addressing there is a zone of low oxygen water in the Gulf of Mexico that prevents most life. Locally, those excess nutrients harm the waterways that you're talking about. So to the extent that natural and nature-based infrastructure can reduce excess nutrient pollution to our local waterways that flow downstream to NOAA's area of trust resource, we have a significant interest there.
Wonderful, wonderful. I think I got just a few more seconds to ask my last question. Dr. Bridges, concerning the durability and resilience of infrastructure projects over the long term, it is important to recognize that these nature-based infrastructure features are often paired with traditional infrastructure. For example, in Iowa, we have a revolving loan fund that pairs these two approaches to improve water quality. The Army Corps of Engineers implements this approach as well. Do you agree that it is important to evaluate the pros and cons of different project features over the long term when it comes to cost, effectiveness, and durability? And I've got about 15 seconds.
Yes, thank you, Congressman, for the question. Of course, it's important to compare the costs and the benefits. I think one of the things that we're seeing happen in the emergent science with regard to nature-based solutions is how do we evaluate costs and benefits in a comprehensive fashion, as opposed to a narrow view of costs and benefits. And there's a lot of progress being made on this front. And Dr. Thur referred to the importance of the social science in respect to this. I was actually in Iowa this summer on my trip, and I actually put my feet on the ground on some nature-based solutions in the form of what we call in the Corps of Engineers levee setbacks along the Missouri River, where we're restoring floodplain, increasing potential for flood storage, and importantly, relieving pressure on the conventional infrastructure that's being challenged by high flows. So there are tremendous potentials in states like yours to do this and to capture these costs and benefits in the broadest possible way.
Well, thank you, Dr. Bridges, and I'm glad you had your 2 feet in heaven there. With that, I yield back.
Ms. Fletcher is recognized.
Thank you so much. And thank you to Chairwoman Cheryl and Ranking Member Bice for holding this hearing today. And thanks to all of our witnesses for taking the time to testify. I've enjoyed all the testimony. It's been very helpful. Dr. Bridges, I couldn't help but notice in your testimony, you mentioned your work on a project in my region, your work with the Galveston District of the Army Corps of Engineers on the Texas Coastal Spine Project. And for those less familiar with the project, this project includes both hard and nature-based infrastructure along the Texas coast to protect the coast, including, importantly, the Houston, Galveston Bay area to protect us from storm surge and flooding relating, rising during hurricanes. And it includes the restoration and creation of marshes and dunes and reefs and breakwaters and a lot of really innovative and important projects that I know our constituents are very excited to see get done. The Chief's report was just published last fall, and so it is now time for Congress to authorize it in WRDA this year. Nature-based solutions are very important to my constituents in Houston. We see it in the Texas Coastal Spine Project. We see it in the Buffalo Bayou and Tributaries Resiliency Study. These are issues, these are things that my constituents want to see us doing more of. And it's important to us in our area where we have had repeated flooding and storm surge affecting our whole region. We, as my colleagues on this committee, I think know by now, we had 3 500-year floods 3 years in a row, one of which was the result of Hurricane Harvey, which was the most significant tropical cyclone rainfall event ever recorded. It dropped 9 trillion gallons of water along the Texas coast, and it caused more than $125 billion in damages. So these issues are top of mind for my constituents all the time. Now, what we hear, the scientists who've come before this committee ever since I've been in Congress have told us that storms like these will be more frequent and they will be longer in duration because of climate change. And so with that in mind, I want to direct really 2 questions to you. I want to start with Dr. Bridges. Just how can you talk a little bit about how the Corps and the projects that you work on take into consideration that the conditions will change over time because of climate change? And certainly we've seen that again this week with the most recent reports. So how do you take that into consideration as you're working on these nature-based projects in particular? And then I have a question for all the witnesses after that.
Okay, I'll try to be brief and to say I think it's increasingly important that when we do planning for projects of the scale of the one that you mentioned along the coast of Texas, that we consider in an imaginative way the scenarios that could play out that our infrastructure is going to be challenged by. Because if you had asked anybody the month before Hurricane Harvey whether or not Houston was going to get 50 inches of rain in 10 days, everybody would have said no. So we have to be creative and imaginative if we want to develop resilient systems. Both words are very important, resilient systems. And resilient systems, I think, can be developed importantly by trying to leverage what nature and what the landscape in that area can provide and support. And that's the work that we're doing with our Galveston district. And they're very much on the forefront. They're leaning forward in doing this kind of work. And I think the rest of the Corps has an opportunity to learn from them and their work in Texas. And we're happy to support them by bringing in elements to help create this this broader imagination for what our systems are going to be challenged by in the future. Thank you.
Well, thanks so much for that. And I agree with you on the strength of the Galveston district, in particular of the Corps. They've got great leadership and they've really been very good partners as we address these most pressing issues for our community. So I appreciate your answer there. And I do think it was unimaginable to us as well. And we in Congress and in the government need to do that imagining. We need to think about all of the things that could happen, especially as we talk about what can happen in our communities as a result of climate change. And so that was my next question, is kind of for anyone who wants to take it. Just wondering what additional types of research and development at the federal level, whether it's at the Corps or whether it's at NOAA or another agency, what would be most helpful to you in providing the best options to protect the Texas coast, but coastal areas all across the country in light of rapidly changing climate?
If I may?
Yeah.
Thank you for the question, Pam. There are a wealth of projects that are being implemented along our coasts and in inland areas that are using nature-based features. There are at least a dozen or more programs that are funding those. The vast majority of those are focused solely on implementation. There are relatively few programs dedicated to the long-term monitoring and research so that when our nation reinvests in nature-based infrastructure following the next Superstorm Sandy or with the next Infrastructure Investment and Jobs Act, we have the knowledge we need to develop these more effectively. And so I would identify for you, there is a potential gap in the research mandate and potentially funding along with these large implementation projects that we have had authorized.
Okay, thank you so much for that. I have now exceeded my time, but I think that's very helpful guidance for our committee as we look at how we can best support this work. So with that, Chairwoman Sherrill, I yield back and thank you again for holding this hearing.
Mr. Gonzalez is recognized.
Thank you. Thank you, Chairwoman Sherrill and Ranking Member Bice for holding the hearing and to our witnesses for joining us. Dr. Thur, I'm going to jump right in and touch specifically on the Great Lakes. I'm from Northeast Ohio, have enjoyed the Great Lakes for my entire life. And as I'm sure you know, they are experiencing record high water levels and severe storm surges that continue to significantly erode many bluffs and beaches across the shoreline and put more and more communities at risk for flooding and water quality impacts. Something I'm seeing every single year. And as a kid, I don't remember ever seeing this much flooding or hardly any flooding at all. Although nature-based infrastructure presents a promising solution to an increasingly difficult challenge, which I just highlighted, its use remains quite limited in the Great Lakes due to limited funding opportunities and general uncertainty in performance. Can you expand on the current state of performance research and perhaps where Congress can be more helpful with respect to funding opportunities?
Thank you for the question. I can provide a response in a couple of ways. So NOAA has a regional integrated science and assessment program that works regionally with states. And in the Great Lakes specifically, they have worked with 12 cities within the Great Lakes broader watershed to co-produce municipal vulnerability assessments. They are attempting to use both federal resourcing, technical skill, as well as funding and local knowledge to determine what can be done to manage stormwater through, among other things, nature-based infrastructure. And one of those municipalities has been successful in issuing the largest environmental impact bond for $54 million for natural infrastructure within their city. And so I think that's an example of how to use science and local knowledge to leverage additional non-federal resources through the bond issuance. I would also state that in terms of the research gaps, the answer that I provided to the previous question, we are funding a fair amount of infrastructure investment, but we're not coupling that with a mandate to conduct long-term research of those projects.
Thank you. And obviously the long-term research component is critical. I think critical, frankly, to solving most of our science-based problems. We can't have this uncertain funding stream, but to have long-term funding in place, I think gives your community and everyone a fighting chance at solving some of these challenges. Dr. Thur, I'm going to stay with you and again focus on performance. One of the hurdles facing nature-based interventions is the lack of indicators and metrics for measuring effectiveness, because each project has different context-specific factors that can fluctuate over time, such as financial capital, frequency and intensity of natural hazards, and what the local communities themselves consider effective. Would simple standardized metrics of nature-based interventions help alleviate this problem? Is that even possible given the dynamics? And if not, what other alternatives should we consider?
Thank you for the question, and it is a great one, and it is an area of active research. I think Dr. Bridges has mentioned both an atlas and produced some guidelines along with many other partners that help practitioners understand where engineering with nature solutions may be most effective. It is true that there is complete local context for the use of these features, but I think it is also the case that there can be some specific measures that are incorporated that give indications of appropriateness by habitat type or nature-based feature type. And so I do think it is always going to be a combination of higher level guidance that has some loosely used standards, I will say, and some local context and implementation, because as you indicated, the contexts are so individual specific.
Yeah, thank you. Well, a unique set of challenges for sure. But I want to thank you again and the chair for holding this hearing and all of our witnesses, and look forward to supporting your work. Thank you.
Chairwoman Cheryl, all members present have completed the first round of questions, so we shall begin a second round. And Chairwoman Cheryl, you are recognized.
Thank you. I asked for a second round of questions because I do have one burning question that always plagues me in these hearings. As we've heard some fantastic ideas, some actual projects that have taken place that sound like they could be very helpful in some of the towns in my district. And I just, as I sit here, wonder, it seems so difficult for my local mayors and the local town engineers to get access to this information, understand how to implement some of these programs, understand the cost benefit analysis that we've been talking of some of these programs. And that's partly why we're holding this hearing, because while we've heard some of the green infrastructure can be utilized quite well, and certainly in a place like New Jersey, the most densely populated state in the nation, we're very careful about our land use now and conserving our land and determining the balance, because of course we always have a lot of development going on as well, and how we best do that. But getting this access to this information and understanding how to balance the decisions sounds, it seems like my mayors don't have access to this, or my town engineers don't have access to this. Do any of you have a sense of how they might get that access and what we might do better, how we might do better to help them?
If I can take this question. Currently, through our partners in data innovations with ARS, we are working to not only grab that monitoring data information, but bring it into our servers and stand it up through a decision support informatics platform where we can easily share this information, this data, bring in other data from other resources, couple it and integrate real-time data with historic data that will be accessible to scientists, to stakeholders, like you mentioned, emergency managers, where we can share models, where we can ask the expert, for instance. And so, yes, ARS is heavily involved in that. And that's a lot of what we're doing through collaborations with other federal agencies, with our state dam safety officials, academic institutions to bring this to fruition.
If I may also.
I might add on to Dr. Hentz. Oh,
I think we've lost Dr. Bridges.
Okay, I just
Dr. Bridges, we've lost your feed a little bit. You're in and out.
We've taken we've
I'm sure. Darn it. Dr. Thur, do you want to go? And maybe we'll try again with Dr. Bridges right after.
Thank you, ma'am. I would say we recognize that there are certain things us as a federal agency are well equipped to do, conduct some research, fund some direct implementation. We also recognize there are things we may not be best positioned to do, and community outreach may be one of those. And so within NOAA, we fund specific programs that at the state level employ specific individuals to do that connection to the science at the local level. These include our Sea Grant program, which are present in all of our coastal and Great Lakes states, the Regional Integrated Science and Assessment Program I mentioned earlier, and even the Coastal Zone Management programs. And so these are state or university employees provided funding by NOAA to do just what you were asking about.
Thank you. And finally, Dr. Bridges, want to try again?
Can you hear me now?
I think so.
Can you hear me now?
Yep.
Okay. Well, I was emphasizing we made a big investment in our public-facing website for Engineering with Nature, and using that website actually as a broad repository for information about nature-based solutions. We actually launched a podcast for Engineering with Nature. You can subscribe to on Apple and the travel. And these audiences are lay people audiences, so that they can be more aware of the options that are available to them. And we get a lot of feedback. I've been contacted by city engineers before because they listened to a podcast that we had. So our point, we do need to invest in outreach and be very deliberate about that to share this information to the local, regional level. Thank you.
Well, thank you. And I hear you were in God's country, but I don't know which part of New Jersey you visited on your trip. But without further ado, I will yield to our ranking member, Ms. Bice.
Madam Chairwoman, I don't have any additional questions for the witnesses.
All right. Well, thank you all for indulging me. A fantastic conversation, and I really appreciate all of your time. It's been really a wonderful discussion. So before we bring the hearing to a close, I want to once more thank everybody for your testimony. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. So the witnesses are excused and the hearing is now adjourned. Thank you all so much.
Thank you all.
Thank you.